For the future, what we really like to do at Labfront is to create a detailed actigraphy report. Again, this is a raster plot that was generated by an individual over the span of a month, and you could see the sleep patterns throughout the week. We can obviously generate nightly reports where you could talk about sleep efficiency, time in bed, etc. But then we also are planning to generate multi-night reports where it shows standard deviation of all the measures, onset, offset, mid-sleep duration, interdaily stability, because we can do that using actigraphy, social jet lag index, SRI. CPT may be a little bit challenging because the chronotype is a little complex to do, but we hope to do that. And when it comes to consumer wearables, there is a algorithm. There's a whole stepwise process. You take the acceleration raw data. This gets converted into activity counts, which then converted to sleep wake classification. And then subsequently, you can calculate your sleep regularity index. And what's been done in the literature is, let's just say the UK Biobank used the activity wearable. This one, unfortunately, can only do about a week, and you have to ship it back in order to get back the data. It requires 100 hertz of raw data. Use the open package GDIR, which is our program analysis system. The activity count is done almost every 5 seconds, although it's not entirely clear. And then you have a sleep wake classification of 30 seconds. And then you can calculate the sleep regulation using sort of the two open packages, open source packages using R or Python. You could do the same for Camentech, which also was done by other groups, and this was their stepwise process. But there's no reason why we can't do this using Garmin's, and this is our intent to incorporate. Again, we're able to get raw data, we're able to get activity counts. We apply our cold crypt key, our SATI method. We can also incorporate the open package GGR as well, and then apply this and then produce the report for you using the proven algorithms that's been published out there. The final two things is, again, the question of correlation versus causation. It's unclear whether low sleep regularity actually causes chronic disease or whether this is just more of a correlation or not. And for the future, then, it would be good to see, does instituting high sleep regularity actually improve or reverse ill health and lead to healthiness or good well-being? And so that's going to be in the future. And then the other thing is we are able to assess sort of behaviors, but getting access to our internal circadian rhythms is a little more challenging. But there are options that are out there. There is obviously salivary cortisol and salivary urinary melatonin, but that may be a little bit, I guess, invasive in terms of the amount of time that requires the day to day in order to do that, or hour to hour even. But there are options for obtaining core and distal temperature, heart rate variability, which seems to correlate with his internal circadian rhythms, and we're going to continue to evaluate that. And then the next step is finding the best way to visualize the sleep regularity so that participants themselves can interpret the data and take the next step.